4. Which of the following could not be the product of hydroboration-oxidation? So what do we know about hydroboration-oxidation? We know that it is an anti-Markovnikov hydration. So we know that we're starting with a pi bond somewhere, and we know that we are adding H and OH, and we know that the OH is going to the less substituted carbon that is participating in that pi bond. For each of these potential products, what is the substrate that it could have come from? Looking at A, this one makes perfect sense. If we had this as the substrate, then the OH could have gone to the less substituted carbon. That works just fine. Then let's look at C. We could have started with this substrate, and the OH could have gone to the less substituted carbon. That works just fine. Looking at D, this is a slightly different situation, but it actually does work just fine. The hydroxyl could have gone there or there because they're both secondary carbons, but this is one of the two possible products. It is not necessarily the dominant product, but this asks which of the following could not be the product. This could be the product. It's one of two potential products. So D actually works fine as well. B is the one that is not going to work, right? We're looking at a situation where the hydroxyl is on the most substituted carbon. So it doesn't matter where we put it, if we put it there or if we put it here. In neither case would the hydroxyl end up there. In this situation, the hydroxyl would end up there, as we saw in option A. If we did it here, then the hydroxyl would end up there. There is no way to get B as a hydroboration-oxidation product. That would have to have preceded by a Markovnikov hydration route. So B is the one that could not be the product of hydroboration-oxidation. That is not a possible anti-Markovnikov hydration product.